Okay, problem number 12, last but not least. So, given parallelogram, that's going to turn out to be important. Parallelogram ABCD with these vertices. I'm just going to sketch that out. Actually, read out the entire thing. Um, that parallelogram ABCD is a rectangle. Now, they're not going to ask you to prove something that's impossible. Right? So we can do this. So we're going to sketch out my diagram. It's going to make it look like a rectangle. And its mean is A, B, C, D. So you take 24 quadrilateral, and you go clockwise median, or counterclockwise if you like it. So A going clockwise, B, C, and D. Right? So there's my quadrilateral, so my parallelogram. I need to show, I need to prove that this thing is a rectangle. So here's my little cheat sheet of how to prove that this is a rectangle. Well, the first thing they say, one, is that you have to show that the figure is a parallelogram. All right? I already know that the figure is a parallelogram because they gave it to me. Given parallelogram. So I don't have to do any of the stuff above, which was in problem number 11. Okay? So I simply have to do one of the following. All right? I have to either show that the figure has one right angle or that the diagonals are congruent. Now, to show that the figure has one right angle, that's two calculations, all right? That would be this side perpendicular to that side. That would be two slope calculations. Now, I'm not very good at slope, so I'm not going to do that one. I'm going to do the second one, all right? And that is also two calculations. If I can show that diagonal AC is congruent to diagonal BD, then I've proved that this is a rectangle because I've done one of these and I've already got a parallelogram. I'm going to do the distance method. If you like, you can do the slope method, but I'm going to go with distance. So the two things I need are the length of AC, the length from A to C, and then I also need the length from B to D. B, D. So length, right? To show things are congruent, that's length. I'm going to use the distance formula. Um, I'm going to use the distance formula fairly quickly. It's a radical, and I'm going to take the difference of my x's and square it, and then the difference of my y's and square it. So I'm looking at C. Okay? And since I'm doing difference of my x, it's difference of my x is minus 5 and 2. Oh, minus 5 and minus 2, that's minus 7. Okay. Now we're going to do the y's. Right? I want the difference between minus 1 and 3. Well, minus 1 and minus 3, that's minus 4. Negative 7 squared is 49. Negative 4 squared is 16. 49 plus 16, that's 5, 1, that's 5, and 1 is 65. This is radical 65. Um, I'm not even going to think about simplifying this because nowhere do they ask for simplest radical terms, and I need to keep in mind what I'm doing. I want to show that AC, that this length, radical 65, is going to be the same as BD. So I'm going to leave it in the form that I have there because if I simplify AC, then I'm going to have to simplify BD. It's two extra steps, so I'm not going to do that. Okay? So I've got my length of AC, and I need to repeat this process for the length of BD. We're going to take the distance formula. It's going to be the change in my x's plus the change in my y's, both squared, and then we square root. So now I'm looking at BD. Now I'm going to change to the change in my x's. I'm going to use fraction. That's going to be that minus 2 and that minus 1. Well, a negative and a negative makes a positive, so it's really minus 2 plus 1, which is minus 1. Okay? Now we repeat the process for the y. I want the change in my y's. So it's a difference, minus 3, and that 5. Well, that's minus 3 and minus 5. That's minus 8. Well, negative 1 squared means times it by itself. It's a negative times a negative. 1 times 1 is 1, positive 1. Negative 8 squared is 64. This is radical 65. So the length of BD is in fact equal, right? Well, we can say that. We're going to say AC equals BD. Okay? So I've done my calculation. Okay? Not that one. I've done this one. And I already know that it's a parallelogram. So I have everything I need to write up my proof. When we write a proof, if they're asking us to prove, we would say parallelogram ABC is a rectangle, and then we'll insert our statement. Parallel ABC is a rectangle because next thing we see is the method that we use. We've already said this one, right? It gave it to us. Now we just state this and then tell them why. Because the diagonals are congruent, and then tell me why. Tell me how you knew they were congruent. They both have a length of radical 65. Period. And that's it. We are done. Let's check our proof. Parallelogram ABCD is a rectangle. That's what they gave us because the diagonals are congruent. The one condition I had to show. And here's why I know they're congruent. Because they have the same length, and that length is radical 65. And there's my calculations to support it. So, done with the proof. Very nice.